Okay, continuing with Mars, we're going to look at some more of the major features of Mars. First of all, I mentioned in the previous lecture, that Mars is small. It's only about half the diameter of the Earth. And you throw that in with a slightly lower density, and you have 11% the mass of the Earth. That's why you would weigh quite a bit less on Mars, a little more than a third of what you weigh here on Earth, which is interesting. And there you see the density. Just for reference, I believe Earth is at about 5,500 kilograms per cubic meter. Mercury is about the same as that. Venus at 52. So Mars, a little less dense, and we kind of see that trend in the solar system where things get less dense the farther you go out into the solar system. No surprise. Okay. Mars, hey, we finally have a planet with moons. So we had Mercury and Venus with no moons. Mars has two little interesting moons, Phobos and Deimos. Phobos and Deimos come from the Greek mythology. They were the sons of Ares, who was the equivalent of Mars, and Aphrodite, who of course was the Greek equivalent of Venus. And we'll see those moons later in the chapter. Some of the things that future colonists on Mars will probably like. One thing in particular, the daytime on Mars. Now, to not be confused, NASA calls them sols, S-O-Ls. They use that to great effect in the movie The Martian with Matt Damon, talking about how many sols he's been on there and that he needs to survive and so forth. So look at that, 24.6 hour rotation, very, very similar. So the daytime, nighttime, that's all going to seem very, very familiar there. Just in terms of the length of day and night, and you see that the tilt is very, very similar as well. But keep in mind, it's much farther from the sun, so it's much colder, and you also have that eccentric orbit, which is another huge factor that the Martian climate has that Earth does not. So you have to throw that factor in as well. Anyway, take a look at it. So you see there our twin sister Venus, just about the same size as Earth, and a pretty big drop off in size when you get to Mars. It's actually quite a bit more similar to Mercury, but I would say that it's really an in-between. It has some features like those bigger planets, and but the fact that it's kind of a geologically dead world, we think, makes it a little more similar to Mercury in that regard. Okay. Now, I said probably. That's because we don't really have a lot of good information about the interior of Mars. The one time we were going to study it with the Viking missions in the 70s, the equipment broke, and we never really got good data on what's happening inside Mars. Well, guess what? In 2018, which again, when Mars reaches opposition, we're going to send a spacecraft there to land called InSight, and we are going to finally do seismic studies and study Mars quakes. So that's pretty cool. I can't wait for the information from that. We do know that Mars doesn't have a magnetic field, which, by the way, was probably very bad news for it long ago. Probably part of the reason it didn't stay Earth-like. We think it was very Earth-like early on, but without a magnetic field, you're losing protection. And why is that? Well, again, it's a small little world. It's probably kind of dried up for the most part inside of it. And so places like that, like Mercury, like the moon, aren't going to have strong magnetic fields. Mercury has a weak magnetic field. The moon has none, and Mars apparently has no magnetic field. It spins fast enough, of course, but it doesn't have the molten core required for a magnetic field. Again, because it's a small cup of coffee sitting in a cold room. And the smaller the cup of coffee, the quicker it cools off. And that's what happened in our solar system. The real big cups of coffee, like Jupiter and Saturn, are still warm inside. The smaller cups, even like Earth and Venus, are still warm. But the really tiny cups, they've cooled off. They don't have much going on the inside. But maybe we'll be surprised from the InSight mission as we learn more. It has no plate tectonics, no sign of that even in the past. All right. So taking a quick look at where we've landed before, I mentioned the Viking missions back in the 70s. Then we landed Pathfinder at the mouth of a river to study that. There's our current rover right there, Curiosity. We've really kind of started to, as you can see, kind of starting to realize the area that we think would have the most potential for life either currently or in the past. And so you notice that InSight is actually landing in the same area as Curiosity. Apparently NASA really thinks that's an interesting area there. So I'm very, very excited about that mission coming up. Can't wait to see what they find out. All right, Mars has polar caps, which is pretty neat. When you think Martian polar caps, though, you should really think more of frozen carbon dioxide, or AKA dry ice. It has regular ice underneath, but there's a big coating of dry ice over the top, which makes it obviously different than Earth's polar caps. These polar caps on Mars change dramatically during the year. During the Martian summer, that carbon dioxide cap is gone. It changes directly from an ice to a gas, which is what dry ice does. We call that sublimation, of course. And so it sublimates in the Martian summer. And that actually has a huge effect on the climate, on the weather, I should say, during the Martian summertime, which is interesting. One of the things that can happen is that the Mars actually looks quite a bit different from season to season, and that's because when it warms up and you get winds blowing and you have no trees or oceans or things, you get huge dust storms on Mars. Absolutely epic, huge dust storms. They learned that with the Mariner 9 mission back in the day when they pulled up and there was a giant dust storm going on and the whole planet was basically covered in dust at that moment. And they were a little stunned by that. So, yeah, and they always portray that in different movies as well. The one thing they usually get wrong is that they have it really super violent and strong. Yeah, the winds on Mars can be fast, but they're not powerful. And that's because the air is so thin. So the thin air may be moving fast, but it's not going to do much to you because the air is so thin. So that's usually something they get wrong. Here you can see just a picture at different times of the year as the dust blows around and some features are covered and some are uncovered, and it looks quite a bit different. We're going to end this section with something that really stunned me when they released this a few years back. We rarely have video. You know, we see all these amazing pictures of space, but you rarely have video from space. So here we go from the surface of Mars. Take a look at this. Yeah, dust devils. I mean, that might as well be, Oklahoma, right? I mean, it's just amazing to me how incredibly Earth-like Mars is. You see that. I mean, sure, temperature-wise, it might be, below zero that day, but certainly would be at night. But, it's not hard to imagine yourself walking around in a place like that. And I hope I live to see that when we actually have, people walking around there and studying it. It's a fascinating world, and we're just getting started learning about it. Thanks for listening.